Today, take you to the closest ticking time bomb in the universe, Betelgeuse. What you're looking at right now is a star labeled by scientists as a cosmic time bomb that could explode at any moment. The red supergiant, Betelgeuse. Before 2019, humanity had underestimated it. We thought it was a stable, slow-burning giant that could shine for hundreds of thousands of years. Then, beginning in October 2019, Betelgeuse sharply dimmed, dropping from its usual magnitude to an unprecedented faintness by February 2020. Brightness fell by more than 2/3. The red supergiant perched on the shoulder of Orion had finally revealed its true, terrifying nature. Betelgeuse is approximately 548 light-years from Earth, though estimates range from around 400 to 700 light-years, making its exact distance one of the trickier measurements in modern astronomy. Its initial mass is believed to have been between 15 and 20 times that of our Sunday. It is roughly 764 times as large as the Sun in radius. To put that in perspective, if it replaced our Sun, it would swamp Jupiter and almost reach Saturn. Its luminosity is estimated at around 100,000 times that of the Sunday. And yet, despite all that furious energy, its surface temperature is only around 5,800 degrees Fahrenheit, far cooler than our Sun, which burns at nearly 10,000 degrees Fahrenheit on its surface. Big, close, and brilliantly luminous, that is what makes it one of the most dramatic naked-eye stars in our sky. And here is the iron law of the universe. The more massive a star, the shorter its life. Our Sun has a lifespan of about 10 billion years, and is currently 4.6 billion years old, comfortably in its prime. Betelgeuse is only around 8 to 10 million years old, and it has already reached the end of its life. Its enormous mass drove nuclear fusion into overdrive from the very start. Hydrogen fuel was exhausted long ago. The core has been burning through progressively heavier elements ever since. When iron begins to accumulate at the core, death becomes irreversible. Iron is the poison of stars. Fusion of iron absorbs energy rather than releasing it. The core will stall, then collapse in an instant. Within seconds, a supernova explosion will be triggered, releasing in that single burst as much energy as our Sun will emit across its entire 10 billion-year lifetime. It will briefly outshine the entire galaxy. No one knows when this will happen. It could be tomorrow. It could be 100,000 years from now. It may have already exploded, and the light simply hasn't reached us yet. As for the great dimming of 2019, that was not a sign of an imminent supernova. The dimming was caused by a dusty veil shading the star, which resulted from a drop in temperature on Betelgeuse's stellar surface. Sometime before the dimming, the star ejected a large gas bubble. When a patch of the surface cooled down shortly after, heavy elements in the gas condensed into solid dust, forming a cloud that blocked its light from reaching Earth. But what it does prove is that Betelgeuse has entered a deeply unstable final stage of its evolution, shedding mass, heaving gas, behaving in ways it never has before. Many people worry that the explosion will threaten Earth. The answer is reassuring. When Betelgeuse explodes, life on Earth will be unharmed. At its distance, the radiation and shockwave will be fully diluted by the time they reach us. But it will deliver an unprecedented celestial spectacle. Betelgeuse will shine as bright as the half-moon for more than 3 months, clearly visible in broad daylight. The night sky lit as if 2 moons were hanging overhead. Every person alive at that moment will witness it. History gives us a precedent. In 1054 AD, astronomers of the Song dynasty recorded a supernova explosion visible in the daytime sky for nearly 2 years. That explosion left behind the Crab Nebula, one of the most studied objects in the cosmos. Betelgeuse's death will be even closer, even brighter. After the explosion, Betelgeuse's core will collapse into either a neutron star or a black hole. The outcome depends on exactly how much mass remains at the moment of collapse. The brilliant red star on Orion's shoulder will vanish from the night sky forever. But it will not truly die. It will become a nebula. It will dissolve into dust, into light, into the raw material of future planets. The iron forged in its core over millions of years will scatter across light years of space, eventually finding its way into asteroids, into soil, into the blood of creatures not yet born. The reason we are so captivated by this red giant is because we finally understand what it means. We come from the stars, and we will return to them. The death of a star is never an ending. It is an eternal cycle spanning billions of years and billions of light years.